Good day to the honorable lecturers. Today, my group and I will be presenting our topic for computer tech studies. Our topic is called Data Science and its Real-World Application. Our group is made up of 6 members: Yap Junhang, Chong Junyao, Vanessa Tan Zixuan, Jocelyn Shok Ziyi, Lee Zhenyit, and Lan Jingyuan. Our topic is made up of 5 subtopics and one conclusion and 1 reference. Subtopic 1 will be explained by me, Lee Zhenkit. Subtopic 1 is titled, What is Data Science and How Does it Work? Data science combines multiple fields including statistics, scientific methods, artificial intelligence, and data analysis to extract value from data. Data science encompasses preparing data for analysis, including cleansing, aggregating, and manipulating the data to perform advanced data analysis. Analytic applications and data scientists can then review the results to uncover patterns and enable business leaders to draw informed insights, if used for business. How data science is conducted. The process of analyzing and acting upon data is iterative rather than linear, but this is how the data science lifecycle typically flows for a data modeling project. A data science lifecycle is made up of 6 parts. Part 1, planning. Planning defines a project, is defining a project and its potential outputs. Part 2, building a data model. Data scientists often use a variety of open source libraries or in database tools to build machine learning models. Often users will want APIs to help with data ingestion, data profiling, and visualization or feature engineering. They will need the right tools as well as access to the right data and other resources such as compute power. Part 3, evaluating a model. Data scientists must achieve a high percent of accuracy for their models before they can feel confident about deploying it. Model evaluation will typically generate a comprehensive suite of evaluation metrics and visualizations to measure model performance against new data, and also rank them over time to enable optimal behavior in production. Model evaluation goes beyond raw performance to take into account expected baseline behavior. Part 4, explaining models. Being able to explain the internal mechanics of the results of machine learning models in human terms has not always been possible, but it is becoming increasingly important. Data scientists want automated explanations of the relative weight and importance of factors that go into generating a prediction and model-specific explanatory details on model predictions. Number 5, deploying a model. Taking a trained machine learning model and getting it into the right systems is often a difficult and laborious process. This can be made easier by operationalizing models as scalable and secure APIs, or by using in-database machine learning models. The final point, monitoring models. Unfortunately, deploying a model isn't the end of it. Models must always be monitored at the deployment to ensure that they are working properly. The data the model was trained on may no longer be relevant for future predictions after a period of time. For example, in fraud detection, criminals are always coming up with new ways to hack accounts.
I'm Jocelyn. Now I will present what technologies are involved in data science. There are linear regressions, logistic regressions, decision trees, support vector machines, cluster analysis, dimensionality reductions, machines learning, and naive-based classifiers. First is linear regressions. Linear regressions is a linear approach for modeling the relationship between a scalar response and one or more explanatory variables that are also known as dependent and independent variables. Secondly is logistic regressions. Logistic model is used to model the probability of a certain class or event existing, such as win and lose, pass and fail, or healthy and sick. Thirdly is decision trees. Decision trees are used as predictions models for classifications and data fitting. The decision tree structures can be used to generate rules to classify or predict target, class, label variable based on the observations attributes. Fourth, supports vector machines supervised learning models with associated learning algorithms that analyze data for classifications and regressions analysis. Fifth, cluster analysis is a technique used to group data together. It is a main task of exploratory data analysis and a common technique for statistical data analysis. Used in many fields including pattern recognition, image analysis, information retrieval, bioinformatics, data compression, computer graphics, and machine learning. 6. Is dimensionality reductions used to reduce the complexity of data computations in order to be performed more quickly. Then, machine learning is technique used to perform tasks by inferencing patterns from data. Machine learning algorithms are used in a wide variety of applications such as medicine, image filtering, speech recognition, and computer vision, where it is difficult to develop conventional algorithms to perform the needed tasks. After that, naive-Bayes classifiers are used to classify by applying the Bayes theorem. There are many used in datasets with large amount of data and can apply generate accurate results.
Hi, I'm Han Yuan, which the group member in charge to present what is the difference between data science and big data. First, look at the big data. Big data is test information or the relevant statistics acquired by the large organization and ventures. And the big data, the ways to calculate the big data is includes the large data set, specialized technique, and customized tools. It's so limited. It's also known as the relative terms. Relate on an entities like persons, company, and more to solve the problem. This is the big data. But because the limited tools, so the big data is difficult to compute the huge data manually. So the big data is just using in the specialized hardware, software, processing techniques, visualization, and database technologies. And then we look at the data science, we compare it together. So the data science can be used in a field or domain which includes and involves working with a huge amount of data. Yeah. So the data science is also can apply in any fields in any size of calculations. So it can use in very complex fields such as mathematics, statistics, computer science, programming, statistical modeling, database technologies, data modeling, artificial intelligence and learning, and predictive analytics, and more. Next, okay, based on the powerful performance of the data science, it has been highly applicable to many fields such as social media, medicine, security, healthcare, social science, engineering, biological science, defense, business, economics, finance, marketing, and geolocations.
My name is Vanessa, and today I'll be discussing the advantages of data science to the transportation industry. Transportation is often used in our daily lives, therefore it is very important to keep improving the industry to provide better services to the users along with improving their safety. This can all be achieved with the help of data science. Next, the benefits of data science. With the help of data, we can use the information we get from car sensors and use them as information on the conditions of assets. With this, we can ensure the safety of the user. Next, we are also able to improve efficiency. By using sensors, data scientists can extract information from all corners of the digital universe to streamline day-to-day operations. As an example, drivers can use their smartphone to look for the closest available parking. With this, we are able to save lots of time. Now I'll pass on to the next member.
Hi, I'm Junior, and now I'm going to present the challenges we face in adopting data science to transportation sector. The first one being accuracy, precision and accuracy. What I mean by this is when we talk about data science in transportation, it's about implementing sensors. Sometimes sensor may not be accurate and the live location may not be precise. For example, when we are using the GPS, the displayed cars on the monitors may not be as accurate as they are in real time. This may cause serious issues such as car crash. Next, I'm going to talk about the expensive cost. The cost to implement those sensors may be expensive because sensors are not cheap. Meanwhile, it may need special care or it will break easily and need to be replaced frequently. Next. Furthermore, we might fall into the hole of data theft. With the advancement in technology, cyber criminals can easily bypass the security systems and steal our personal information. This may lead to bigger issues such as scamming or cyber threats. Meanwhile, for big companies, may have risk in productivity and reputation damage. That's all from me. Thank you.
So we have reached to the last part of our presentation, which is conclusion part. And this part will be presented by me, Yam Chun Hang. So data science will be widely used in the upcoming future in transportation, which we say that in a recent part of challenges, we have talked about the disadvantages of about data science bring to our life. Well, it is not obvious to show that the benefits it's overwhelming to the advantage given, but in the long term of view, the benefits in future of data science will be more or say better than the disadvantages we can see. The benefit brings in future are large than the disadvantage we can see it in nowadays because, for example, like issues like traffic jams are mostly solved because more accurate and efficiency navigation data are used to be calculated out for users to follow. As an example, like we as a user, we use navigation applications like Google Maps or Waze to navigate to the location that we want to go for. So in this kind of period, the application will show us the most fastest and efficiency way to arrive to our location. But in nowadays, this kind of application cannot show the most accurate one because it is not stabilized yet, this kind of tactical. So sometimes we will face a situation like when we use the navigation, we follow the rules it given, and we saw that maybe we will meet some traffic jams, even though we have chosen the suggestion route they given to us. So in these issues, it is seen to be solved. They're able to be solved in the future, so that it will increase the efficiency of our lifestyle, save more time. So this benefit actually it will affect a wide area, which is we can separate it into personal field and public field. For personal field of view, we can see that if we are able to save more time by the benefit given, so we are able to have more extra time to do more things that we want to do. So for public fields, for example, like economical fields, as employee have no problems facing to the traffic jam every day when they went to job, went to work. So they will save more time, and those of time that they save, they will put more on their work. So which is definitely going to increase more of the efficiency of their work. So this is all from us. So thank you very much.